Floors, beams, joist systems, girder systems, subflooring, porches and decks, insulation. What is a floor? A floor is the part of the building with which we have most contact. We walk on the floor and on occasion dance, wrestle, or lie on it. It is bouncy or squeaky, and this tells us something about overall quality of the building. The floor carries the load of our weight, all our furniture, and most of our possession. It also acts as a diaphragm to transfer lateral loads, e.g. wind, earthquake, and soil, to the walls, which resist these loads. Floors insulate us from beneath and often house ductwork, plumbing, and other utilities. So a floor must be carefully designed as a system that integrates with the other systems of a wood frame building, the foundation, walls, stairs, insulation, and utilities. Once designed, the floor must be carefully built because so many subsequent parts of the construction process depend on a level and solid floor construction. Elements of floor system: support, joist, subfloor. Support. Wood floor systems usually span between parallel supports. These supports may be a foundation wall, a stud-bearing wall, or a beam. Joists. The primary structural member of a floor system are the joists, which span between the supports. Joists can be made of a variety of materials and are usually placed on 12-inch, 16-inch, or 24-inch center. Take a look at this detailed illustration. Mid-floor joist connections, joist beam connections, bridging, floor stud wall connections, openings in floor level changes, cantilevers, subflooring and underlayment, floor foundation connection. Subfloor. The planar structural surface attached to the top of the joist is called the subfloor. The subfloor provides the level surface to which the finished floor is applied, and also acts as a diaphragm to transfer lateral loads to the walls. Subfloors are usually made of plywood, but may also be made of other materials. Some subfloors also provide mass for passive solar heating. Let's reference this detailed illustration. Joist or girder. Edge blocking is required if subfloor panels are not tongue and groove and underlayment is not used. Surface grain of plywood subfloor panels is perpendicular to supports. Stagger end joints of the subfloor panels. Offset joints of subfloor and underlayment panels. Floor beam. The drawing and table at the right are uniform floor loads only. Roof loads, point loads, and other loads must be added to the floor loads when calculating beams and headers. Let's take a look at the illustration. Crib and pony walls, beam spans, beam types, connections to foundation, wood beam or girder post connections. Joist system. Wood sheathing aligned with foundation, which is natural with this detail, but also possible with any detail on this page. Let's take a look at this illustration. The one on the left, joists on mudsill perpendicular to wall, framed wall, subflooring, rim joist, floor joist, pressure-treated mudsill, foundation wall. And the one on the right, joists on mudsill parallel to wall, framed wall, subflooring, rim joist, common joist, blocking between rim joist and first common joist-bearing wall above, and resist rotation of rim joist, pressure-treated mudsill, foundation wall. Joist connections. For metal hangers, use common, not box nails. Hanger manufacturers specify nail size for each hanger type. Use construction adhesive at metal joist hangers to reduce floor squeaking. Let's take a look at the detailed illustration. Nailed through joist, the simplest but the weakest method, is recommended only for blocking. Blocked corner, double joists make a strong outside corner for cantilevers and decks. Metal joist hanger. This is the strongest of the standard methods. Each approved hanger is rated in pounds. Nailed with blocking. In this fairly strong and simple joint, nails at right angles effectively lock perpendicular joints into place. It is recommended only for short joists. Metal joist hanger. This is the strongest of the standard methods. Each approved hanger is rated in pounds. Bridging. For deep joists with long spans over 10 feet, local codes may require bridging to prevent rotation and to distribute the loading. Let's reference this detailed illustration. Block bridging. Solid blocking from same material as joist is staggered for ease of nailing. Metal bridging. Metal pieces should not touch each other. Cross bridging. 5/3 inch by 3 inch or 5/4 inch by 4 inch or 2 inch by 2 inch or 1 inch by 4 inch boards are nailed in a cross pattern between joists. Pieces should not touch each other. Opening in joist floor system. Large opening. In openings that are wider than the joist spacing, such as for stairways and chimneys, the floor structure around the opening must be strengthened. For openings up to 3 joist spaces wide, double the joists at the sides and ends of the opening may suffice. Wider openings should be engineered. Small opening. Openings that fit between 2 joists for laundry chutes or heating ducts are simply made by nailing blocking between the joists. Let's take a look at this detailed illustration. Double header joists at the ends of openings. Perpendicular joist connections. Double header joists at ends of openings. Joists, blocking. Floor cantilevers. Double side joists for twice the distance of cantilever. Rim. Rim blocking may be set 1 inch out from sole plate to provide soffit nailing. Note: maximum cantilever equals rated span of joist system divided by 4. Cantilevers that carry significant roof loads or more than one floor load must be engineered. Mudsill, first floor framing or double top plate, second or subsequent floor framing. Double joist in sides of cantilever. Extend cantilever joist twice as far into the building as the length of the cantilever. Joist stud wall connection. Joist floor system connections to exterior walls are straightforward. The wall framing may be one of 2 types. Platform framing, the most common system in use today, takes advantage of standard materials and framing methods. The ground floor and all upper floors can be constructed using the same system. Balloon framing. Balloon framing is rarely used because it is harder to erect and requires very long studs. It may be the system of choice, however, if the floor structure must work with the walls to resist lateral roof loads, or if extra care is required to make the insulation and vapor barrier continuous from floor to floor. Let's look at this illustration. Joist roof connection, if attic floor. Joist interior wall connections, load-bearing walls or partition walls. Joist exterior wall connections. Joist at exterior wall. Joist perpendicular to wall. A. Joist perpendicular to wall. Exterior finish. Stud wall. Interior finish. Finished floor. Subfloor. Rim joist or rim blocking. Insulation and vapor barrier. Floor joist. Finish, ceiling, stud wall. B. Joist parallel to wall. Exterior finish. Stud wall. Interior finish, finished floor, subfloor, rim joist, insulation and vapor barrier, floor joist, 2x4 blocking for nailing ceiling, finished ceiling, stud wall. C. Joist parallel to wall with blocking. Exterior finish, stud wall, interior finish, finished floor, subfloor, rim joists, floor joists. Blocking at same spacing as joists adds structural support and provides ceiling nailing. Finished ceiling, stud wall. D. Double rim joist parallel to wall. Exterior finish, stud wall, interior finish, finished floor, subfloor, rim joist, 1 inch rigid insulation, floor joist, finished ceiling, stud wall. Joist at balloon framed wall. Let's take a look at these 2 illustrations. Joist perpendicular to wall. Stud wall continuous through floor. Exterior finish. Interior finish. Fire block and/or wall nailing. Insulate before cavity is covered by locking. Stud wall. Continuous left-in ledger. Floor finish. Blocking. Subfloor. Floor joist spacing coordinates with wall framing, finish ceiling. Joist parallel to wall. Stud wall continuous through floor. Fire block and/or wall nailing block is required. Insulate before cavity is covered by joist. Vapor barrier behind joist. Exterior finish. Interior finish. Finished floor. Subfloor. Joist nailed to studs. Finished ceiling. Level change. Stud layout must be offset 11/2 inch from joist layout. Continuous studs avoid the cross-grain shrinking of plates in detail. Platform framing. Sole plate. Upper floor system. Single top plate avoids cross-grain shrinkage of double plate. Stud wall between floor system. Sole plate. Lower floor system. Vertical supports as required by loading. Balloon framing. Finished floor. Upper floor system. Let-in ledger for joist bearing. Continuous studs. Interior finish. Joist set bearing wall. Interior walls are either bearing walls, which carry loads from the roof or floors above, or partition walls, which do not support any loads from above. Both types of wall can be fastened directly to the subfloor, but bearing walls must have their loads distributed to or through the floor system with extra framing. Both types of wall may require extra framing where they attach to the floor systems, but the framing in bearing walls will generally be more substantial. Joist set bearing wall parallel to wall. Bearing stud wall, finish floor, subfloor, joist, blocking at 16-inch or 24-inch on center aligned with stud above and below. Bearing stud wall or beam below, studs aligned with blocking and studs above. Note, blocking can be eliminated if bearing wall aligns with joist. Joist at bearing wall perpendicular to wall. Bearing stud wall, studs aligned with joist and studs below, finish floor, subfloor, joists, block if joist is spliced over bearing wall, bearing stud wall or beam below, studs align with joist. Bearing wall is not required if joists are engineered to support top bearing wall. Joist at partition wall. Joist at partition wall parallel to wall. Finish floor, subfloor, joist, ceiling, blocking at 16-inch or 24-inch on center between joists, partition wall, finish floor, subfloor, double joist below partition wall, ceiling. Joist at partition wall, alternative details. Finish floor, subfloor, joist, blocking at 16-inch or 24-inch on center between joists. Oversized 2x blocking provides continuous nailing for ceiling. Partition wall, finish floor, subfloor, double joist below partition wall, ceiling. Wood eye joist. Wood eye joists are designed to work efficiently, with most of the wood located at the top and bottom of the joist where the bending stresses are greatest. Called flanges, the top and bottom are generally made of laminated or solid wood. The slender central part of the joist, the web, is made of plywood or OSB. Eye joists are straighter and more precise than dimension lumber and therefore make a flatter, quieter floor. Their spanning capacity is only slightly greater than that of dimension lumber, but because they can be manufactured much deeper and longer than lumber joists, up to 30 inches deep and 60 feet long, they are the floor framing system of choice when long spans are required. Plywood eye joists. Top chord, bottom chord, chord flange, web, widths 1 5/8 inch, 2 5/8 inch, 3 1/2 inch. Wood eye joists. Let's take a look at these 4 illustrations. Plywood eye joist at rim joist with blocking. 2x4 cripple block at both sides of the joist for 3/4 inch or thinner plywood rim joist. Site-made plywood or laminated veneer lumber rim joist. Pressure-treated mud sill or top plate of stud wall. Plywood eye joist. Subfloor. Note, laminated veneer lumber LVL joists are sized to correspond with depth of plywood eye joist sizes. Plywood eye joist at interior 2x cripple blocks and bearing wall. Bearing wall above, 2x cripple blocks at both sides of the eye joist are the same height as eye joists. Subfloor, plywood eye joist, bearing wall below. Plywood eye joist at rim joist with blocking. Plywood eye joist. Pressure-treated mud sill or top plate of stud wall must be 2x6 for 14-inch or deeper joists. Pressure-treated mud sill or top plate of stud wall. Plywood eye joists. Subfloor. Plywood eye joist at interior, eye joist blocking at bearing walls. Bearing wall above, plywood eye joist blocking. Bearing wall below, plywood I-joists, subfloor. Note, since I-joists can be manufactured in continuous lengths up to 60 feet, they rarely need to be spliced at interior bearing walls. Wood floor trusses. 4x2 wood floor trusses are made up of small members, usually 2x4s, that are connected so they act like a single large member. The parallel top and bottom cords and the webs are made of lumber held together at the intersections with toothed metal plates. The open web allows for utilities to run through the floor without altering the truss. Round ducts from 5-inch to 16-inch in diameter may be accommodated depending on the depth of the truss. Truss depths vary from 10-inch to 14-inch with spans up to 30 feet. Take a look at this detailed illustration. Metal plate, top cord, web, bottom cord. Girder systems. Girder systems may be designed with either dimension or laminated lumber. They are most common in the Northwest, where dimension lumber is plentiful. Girder floor systems are similar to joist floor systems except that girders, which are wider than joists, can carry a greater load for a given span and therefore can be spaced at wider intervals than joists. Girders are typically placed on 48-inch centers, so long-spanning subfloor materials such as 2-inch tongue and groove decking or 11/8-inch combination subfloor underlayment are required. When used over crawl spaces, girders may be supported directly on posts. Over a basement, a girder system may be supported on posts or may bear on a wall or a beam-like joist system. At upper floor levels, girder systems are often used in conjunction with an exposed tongue and groove decking ceiling. These exposed ceilings can make wiring, plumbing, and ductwork difficult. This table assumes a 40 per square foot live load and 10 per square foot dead load and a deflection of L/360. The table is for estimating purposes only. Number 2 Douglas fir is most prevalent in regions where girder systems are most frequently used. Girder systems. 1. Girder systems on mud sill perpendicular to wall. Framed wall, rim joist, pressure-treated mud sill, foundation wall. Underlayment and finished floor, 4 mm vapor barrier, 2x decking spans 4 feet, 4x girder. 2. Girders on mud sill parallel to wall. Framed wall, rim joist, pressure-treated mud sill, foundation wall. Underlayment and finished floor, 4 mm vapor barrier, 2x decking spans 4 feet, 4x girder, bat insulation supported from below. Girder systems. 1. Girders flush with mud sill perpendicular to wall. Note, this detail is not recommended for girders over 4x8 because of potential shrinkage problems. Framed wall, pressure-treated mud sill, foundation wall. Underlayment and finished floor, 4 mm vapor barrier, 2x decking spans 4 feet, 4x girder, half-inch airspace or 30-pound felt attached to end of girder, pressure-treated 4x4 post bearing on footing. Girders flush with mud sill parallel to wall. Framed wall, ledger supports insulation, foundation wall. Underlayment and finished floor, 4 mm vapor barrier, 2x decking spans 4 feet, 4x girder, bat insulation supported from below. Girder systems. Girders with exposed decking. Second floor girders perpendicular to wall. Framed wall. Blocking applied between and to sides of girder supports wall finish. Fill space with insulation. Finish wall. Underlayment and finished floor. 2x tongue and groove decking exposed below for ceiling. Exposed or wrapped girders. Note: 2x tongue and groove decking may be sanded to make finished floor, but this is advisable only with very dry decking. Dust filtration from upper to lower floor and sound transmission between floors may occur with this detail. Second floor girders parallel to wall. Framed wall, blocking supports finish material, fill space with insulation, finish wall. Underlayment and finished floor, 2x tongue and groove decking exposed below for ceiling, exposed or wrapped girders. Note: decking does not provide structural diaphragm required at upper floors. Use plywood underlayment or other method to transfer lateral loads. Floors summarizing: beams, joist systems, girder systems, subflooring, porches and decks, insulation.